Welcome to this channel. So in this video, I want to discuss with that a problem, how to solve the four transactions, how to solve the problem with using Apriori and FE growth algorithms. So in this problem, first we have to represent four transactions and its a minimum support 60% and a minimum confidence 80%. So here we have the four transactions, that is transaction ID and date and items bought. So here you have the four transactions. Now all four transactions you have the items A, A, B, D and C, E. These are the items you have. So in this problem, mainly we have to discuss find all frequent items using Apriori and FE growth algorithms and compare the efficiency of the two meaning processes. And also you can find out the list all of the strong associations. How we can find out? So here mainly it describes first one, how to find the all frequent items using Apriori algorithm. So here whenever you want to discuss with that Apriori algorithm, first you know about the what is the frequent items. So which items are frequently purchased by the customers, that only we have to identify using this Apriori algorithm. So in this problem, we have the how many transactions are there. Here we have the four transactions, that is the transaction ID 100, 200, 300 and 400. So the count the number of transaction 4. And now again you have to count, that is the count the number of transactions for the each item. So first one, A item purchased by how many times? So here you have to purchase it by 4 times. So support count you have to write as 4. And K is purchased only 1 time. So that is simply you can represent it as 1. And B is purchased by 4 times. And D is purchased by 3 times. C is purchased by the 2 times. E is purchased by 2 times. So whenever you have to consider as a 60%, 40, that is the 4 transaction, 4 into 60 by 100. So you get the 2.4. That means we have to consider as 4 and 3 only we have to consider. So now we have to consider the remaining which are less than the 60%. We have to remove all those items. So we have to pruning, that is the compare and pruning. Now we have to, A is the item, we have to purchase it by the 4 times, support count is 4, and B is purchased by the 4 times, D is purchased by the 3 times. So remaining items we have to remove because its support count is less than 60%. So automatically we have to delete the remaining items. And now again candidate generation, that is the C2. Previous one is the candidate generation 1. If this is the 2 items are we have to represent it as candidate generation 2. So now item set we have to present it as AB and AD. So here we have to use AB and AD. So here we have to represent. So consider and then BD. So we have the 3 item sets. And what are the support counts? How many times they have to purchase? Check once here. How many times they have to purchase here? AB, how many times? 1, 2, 3, 4. So its the support count is 4. And AD and support count is 3, and BD support count is 3. So AD, so in the transactions check here. AB is purchased by 1 time, 2 times, 3 times, 4 times. So like this way, we have to support count, we have to calculate it for the item sets. That is the AB, AD. AD is purchased 3 times, its support count is 3, and BD is so its support count is 3. So now you have to compare and prune. Compare prune means less than 60%. So all are greater than 60%. So you have to consider the same values. Again, you have to generate the candidate generation 3. So 3 items you have to same. It's the support count. You have to A, B, D items. You have to purchase. Support count is 3. Okay. Here you have to consider item set ABD. Its the support count is 3. Next one, according to above statements, ABD is the generated whose the minimum support is 70%. So most frequent items is greater than 60. So automatically the frequent item set is ABD. So this is the way simply you can solve the and you can find out the frequent item set using a priori algorithm. So what are the confidence you have to find out? So what are the list of strong association rules we have to generate? So here you have to generate the strong association rules. A, B, D. Only these are the items you have to frequently have to purchase, and we have to represent the strong association rule in between these 2 items. In between these 3 items, A implies BD, and AB implies D, AD implies B, B implies AD, BD implies A, D implies AB. So these are the strong association rules. These are the 6 stronger association rules we have to generate. So simply you can write A implies BD, AB implies D, and AD implies B. So these are the starting with the A, get the 3 strong association rules. Again, we have to consider the B. Here we have to get the 2 other strong associations: B, AD, B, DA, and D implies A. So D is strong association rule 1. So how we can calculate the confidence for these values? So here we have to calculate confidence for these the strong association rules. So A is how many times they have to purchase, that is the 4, and 4 divided by BD, how many times we have to purchase? 3. 4 by 3, that is the greater than 100. So it's the support count confidence is greater than 100. Next one, AB is implies to D. AB how many times? They are 4 times. So and D also we have to purchase it 3 times. 100 by 3, so it is greater than 100. And next one, AD. AD you have to represent it as AD is support count is 3. AD support count is 3, and B support count is 4. So 3 by 4, that is the 70%. But here you're asking minimum confidence is 80%. So you can remove this one. So here you can remove this one, that is the A comma D. You can remove it. Next one, another one, B implies AD, minimum support. Minimum confidence we have to consider. B is 4 times, and AD, so AD is 3 times, so greater than 100. So again, BD is considered as 3, and A is considered as a 4. So here also you can remove this. These are the 2 you can remove. Minimum confidence is 75%. But you are asking the problem, they have to ask the minimum confidence is 80%. So we have to write the transactions, these 2, and this one, and next one is D implies AB. D is the transaction 3 and AB you have to represent it. This is also you have to. Only these are the transactions only. So here I want to draw here. These are the transactions only. So here this one and this one. Only these three transactions are have the minimum confidence is greater than 80%. So these only you have to consider. Okay, yeah. So this is regarding to that minimum support and minimum confidence we have to find out using the Apriori algorithm. And the next one is we can calculate it. We can calculate it here. Find the all frequent items using FP growth algorithm. So in the FP growth algorithm, you have to calculate it. First, we have to write. First, you have to scan the database and you have to write the frequent items. One item set you have to, and the supports you have to write. A, how many times? You get the 4 times. K is 1 time. B is 4 times. D is 3 times. C is purchased by 2 times. E is purchased by 2 times. Okay. Then here you have to consider this is that you have to write. Then after you can find minimum support is the you have to consider as 60%. So that's the reason we have to finally you can get this items are A, B, D. The support count is 4, 4, 3. So how we can draw the FP tree? So FP using the FP growth algorithm. So I want to draw here. See here, this is the first one is null node. Here you have this is the null. You can write here null, and then after this is the A. I have to write. And its link is you have to assign like this. First one is A. First transaction you have to consider A, and the second transaction so you have to represent it as count is 1. See here another transaction KABD. So here we have the four items. 4 items are there. And out of 4 items, you have to use the ABD. So A is the first one. You have to represent it as starting with the support count is 3. So next one is the you can write the B as well as D. So here. So next one I have to draw B. Here you have to write. This is the you can write B. Next one in next transaction D. So D only you have to consider here. Next one is the transaction you have to write D. This is the one. Next one you have to next to see the another transaction A is there. So next one B is also there. You have to write 2 and D also you have there. Next transaction you have to consider D. 2 is there and the next transaction 3, and its support counts is totally you can get the for the ABD. So ABD you can get the its support counts is 3. This is the way you can draw the FP tree using FP growth algorithm. So this is the regarding to the FP growth algorithm, and how the list of the strong association tools here. See here, last one. List all strong association rules. So previously, what you have to write the string or also association rules. These are the strong association rules you have to write. This one, and this one, and this one, these two, and this two. So totally 3. These are the strong association. Thank you for watching.